there's two directories supplied, two bunch of files supplied with this video. This is the first one. Here's the second one. So we'll start out with this one, which is the incorrect one. We have a lot of different textures here. We have the specularity of the character and such. A lot of FX textures, all of this, and we'll have to end up with just this. Now some of these are also example files we won't use anyway, like this one is incorrect, and this one is incorrect and a duplicate of that. But all in all, we can easily combine all of this and reduce the memory of the whole thing to just these couple of files. We can easily half the initial memory, at least half the initial memory, perhaps even go to 60-70% reduction in memory footprint through efficient use of the features you have in Unreal. Right, so let's get going. I'm going to import those files. So I'm going to import, let's say, let's just start with a normal map. The N at the end of a name, for example, taillog body, N stands for a normal map for the body of the monster. Monster is called taillog, by the way, which is an old Mexican word, or Nahuatl, I believe it was, which was the language of the Aztec. So we can start with a normal map, either the armor one or the body one, and let's just import that. Make sure you import it from the unfinished directory, not the finished one. Again, like explained in the first tutorial, in the first video, I usually make two packages per bigger package, basically. I name the first one as development _2 textures, and in the texture one I'm going to place all the textures, and in the asset one I'm going to place all the materials and all the meshes, because like explained in the first video, that will help you not having to update this huge texture file all the time, because the package that contains the textures, that's the package that's most likely to grow fast, and that's the package you will probably have to upload to the server a lot of times. So in order to save some bandwidth, in order to save server space, I tend to split it up as explained in the first video. So I'm going to do it like that. I'm going to leave the properties here at the bottom B, as I will get back to that in a bit as to why that is the wrong thing to do. So I just import it, and this is how most people would import it, I guess. They just simply hit import, it's in, and then they consider it done, but it's far from finished. So I'll save it right away. So here's a normal map texture, we simply import it through this. That's incorrect, however. When you import it, what you should have done is and I will now import the armor. You should have selected normal map in here, compression settings. So these compression settings, you can pick different things here. And the majority of them is actually rather useless or very, very specific, but the default one, a normal map, does make a big difference. If you pick normal map, it will automatically set all the other settings correctly. And that's important because following settings are really important. There's an sRGB, super RGB here at the bottom. That should not be on for normal maps ever, because this is basically gamma correction. It's going to change the brightness of the texture. And you don't want that to happen on a normal map, because the color of a normal map has to be 100% accurate and correct, since it's going to use this to deform the lighting hitting the model. So you can't have this on a normal map, but on any other texture you should have sRGB on, but never on a normal map. Also, there's a setting here, unpack max and min. This should be -1 on minimum, and the third one should be 0. A normal map needs to have unpack max and min set up like this, and not with the default settings. And thirdly, there is a lot group here that says world. That world should have been world normal map, or if you wish, character normal map or weapon normal map, etc. So this classifies the texture as being for a certain use, and having it on world is incorrect. It should have been world normal map or character normal map or whatever it's meant for. So I'll set it to that. Plus compression is normal map to begin with. Okay, so now it's correctly set up. So again, it has to be compression normal map. The lot group has to be something normal map something. Character, since it's meant for character in this case. sRGB should be off for normal maps, not for other textures though, and unpack min should be -1 everywhere except for number 3. If you import a texture and set it to normal mapping right away, if you select compression settings normal map, it will immediately do all of that. So the compression setting is correct, sRGB is off, and this is set to -1. Plus this is set to world normal map by default. So the lot groups, it classifies what the texture is meant for. And that matters because, for example, if you have a PC game and you go to the settings menu, it's most likely going to say there world texture detail low, medium or high. And it's going to say there character texture detail low, medium or high, etc. It's going to allow you to bring back the texture detail on parts of the game. Well, in order for the game to know what parts it has to reduce, you have to manually tell it this texture, this is a character texture, and this texture here, that's a vehicle texture. If you don't do that, it will class everything as being the same, as being world. That usually doesn't have a particularly big impact. I mean, you could get away with just putting everything to world. I wouldn't advise it. But there are cases already also where this has a very big impact. For example, the UI one is treated entirely differently. When the game is cooked at the end of production, or not necessarily at the end, but when the game is cooked, it will take all the UI textures and place them in a different container, and it will never stream them. So the texture streaming happens when it loads in a very low resolution version of the texture first, and then it streams in the higher resolution at a later point. Well, it will never do that with the UI texture. So if you fail to set this correctly, you're going to get a very blurry interface, for example. There's a lot of those kind of things. So the classification should be rather correct. This classification can also be found in the ini file. So here is install directory of UDK, UDK game config. Now there is a UDK system settings.ini here, and related to that there is going to be a default system setting somewhere. I failed to see for a moment. There should be a default system setting somewhere here. I can't see it right now, but alright, just there. These two also control the lots. They are called lot groups. So those lot groups are controlled by the ini file. If you open one of them up in Notepad, and we go through, at some point we'll come across this big list here. These are the lot groups found in the editor. See, here we have world, world normal map, etc. We can now say per group what the maximum allowed size is. So the maximum resolution of a world texture is allowed to be 4096. So if I now say I want all my characters to be clamped to 1024 maximum resolution, the game will never display any character above 1024. Also you can say, okay, it's very nice my game, but it's too big on the memory. Then you can take lot bias and bring it down. You can put it, for example, on 1. Now it will halve all the textures automatically. So these are topics we'll get back to in a bit, but this basically controls this. So if you fail to set this correctly, you can't later on control it via the ini file. And the game can't scale down parts of it. So also, as you can see here, there is something called lot bias. Like I said, if you put it to 1, it will halve the texture. And you can already do this in the editor. You can see here you have lot bias here as well. It's 0. 0 means it displays it at the current resolution. You can see it's import as 2048 here. And the maximum in-game allowed is 2048 as well. So the actual resolution is 2048 and it will display as 2048 in-game. If I now set this to 1, maximum in-game becomes 1024. If I set this to 2, maximum in-game becomes 512. So you can scale down a texture using this property. And this also allows you, now it's 256, this also allows you to see what the texture would look like if it were scaled down. This is now a lot bias 4, texture is 128 by 128 resolution. This is something the game does automatically, or when you change it in the settings. So if you go to the settings menu of a game and you say, okay, my computer can't handle it, I'm going to set all texture detail to medium, the engine actually does this. It brings it down or raises the number, and then if it's still too much, it will do this, etc. The engine also does this over distance. So let's say that this normal map is currently assigned to this character. If I move away from the character, if I move away from the object using the texture, the engine will step down the resolution of the texture. So at a certain distance, it will automatically half the size. And if I move further away, actually it happened almost right there, could have been a shadow as well, but you can see a small clip there. At a certain distance, it will switch to the next one. And if I move further away even more, it will switch to the third. So the more further away you are from an object, the more it begins to reduce the size. And why does that have an impact? Well, obviously it has an impact on how much memory the game uses, but for you as an artist, there is following bad example. I made something here called taillock body D incorrect. So that's the diffuse texture of the monster. And it has a white background. Well, that's incorrect because of the lot bias. If I also quickly import the mesh, it might be rather subtle to see in the video, but what happens is that the pixels will begin bleeding in. So this is also a very important thing, is the background texture of whatever you have, the background color should always be the same as the average color of the texture, or a rather dark color, or black if you wish. Black is fine as well, but never white, never green, never something that will totally stand out. Because you're gonna see this in the texture, you're gonna see a seam show up. And no matter how good you set this up in Max or Maya, or in ZBrush or whatever you're using, the moment, since the engine will downscale the textures, or the user will downscale the textures via the settings menu, the moment it scales it down, it will begin blurring the pixels. Because if you were to half the resolution of this texture, these pixels would begin to blur together a little bit more, and because they blur together, you will start seeing seams. So if I increase the lot bias here, you can see the seam is only getting bigger. And at some point it looks like that. So no matter how well you would set this up outside of Unreal, the textures, since the engine will downscale the textures based on distance and based on computer power, you're gonna start seeing this. Now if the background were to be black, it wouldn't be so obvious. But now it's very obvious. See, that happened here as well. If you move away, you see a clear white line. That's because the texture is now half the resolution as it is when you're up close. So that's a very bad idea there. I occasionally use lot bias to, for example, in a mechanical, because we have very limited memory there, because it's an iPhone game. There were cases where the texture was really too big. But rather than exporting it to Photoshop, resizing it there and importing it in, which I could have done, would have saved disk space as well, I can also just type 1 here. And now I basically half the texture in game. It's still the original size in the package, but it will never be displayed at that size, and it will never load the original size either. It will already immediately load the smaller version of it. You can also do is type a negative number here. You can type -1. And if you type -1, then the texture will remain sharper for a longer period of time. And also when the user, for example, goes to the settings menu in game and he says my computer can't handle high-res characters, I'm gonna set all characters to medium detail. Then what the engine would do is it would type 1 here. That would mean medium texture detail. However, because you type -1 there, it would do -1 plus 1 is 0. Therefore, the texture would still display at original resolution. So you can also type negative numbers here to offset the engine. So now it will not scale down the texture as fast when you view it from a distance, because it's basically the number, you're offsetting the number. It could be a bit hard to understand, but that's the trick I sometimes use. I sometimes manually enforce a lower resolution than it has, or I manually make it keep its current resolution for a longer period of time. The next thing is MIPGen settings here, and basically every step down is a MIP map. So now I'm on the first MIP map, second MIP map, third MIP map, fourth MIP map. So the engine automatically makes these different maps. When you import a texture into Unreal, it takes the TGA file you imported, the BMP, whatever format it was, and it converts that into a DDS file internally. So that conversion process both compresses the textures and will generate the MIP maps of it, and those MIP maps are then stored as separate images within the DDS file that it made internally. Now unfortunately you can't make these DDS files yourself. Most engines can. I believe the Skyrim engine, for example, is able to do that. Unreal Engine 2 was able to import DDS files. Hopefully Unreal Engine 4 can do it again, but Unreal Engine 3 apparently for some reason doesn't allow people to import DDS files. Now if you were able to import DDS files, what you would be able to do is you would be able to manually make them in Photoshop, and that would give you total control over how those MIP maps are generated. As it is right now, when you import it into Unreal, you just have to hope for the best that Unreal downscales your textures correctly, which it doesn't always do. That's where the settings come from. So in the settings, these MIPGen settings, this is how it generates those MIP maps. If we were to change that to, for example, sharpen 5, it would sharpen it with, number 5, fifth intensity of sharpening. It would sharpen the MIP maps it generates, therefore it would probably look a little bit better. Likewise for blurring, and you can also put it to no MIP maps. If I put a texture to no MIP maps, it does not generate any MIP maps anymore. Therefore, if I then raise the lot bias to 4, there is no actual difference. Even if I type 9, it still looks identical because the MIP maps have been removed. You could do that, but if you were to do that too much, or on the wrong type of surfaces, it's going to look very pixelated. Because the MIP mapping doesn't just help the memory, it also helps to smooth the environment together. If you look at an environment from a distance, it should look indeed a little bit more blurry. It's a bit of a very simplified depth of field. Everything in the distance gets a little bit more blurry. If you remove MIP maps, you take away that possibility of blurring things in the distance, and it's going to look more pixelated, it's going to look more noisy. So I usually never take MIP maps away, but I do tend to put everything to sharpen 3, 4, 5. This kind of range seems to work quite well. It's not too much, it's not too little. So for example on the ball, all the textures in the ball, all the characters, all the weapon, the vehicle, the entire environment, everything is pretty much set to 3, 4, 5, 6, somewhere in this area. And that does make the game look a little bit sharper and a little bit more defined. You can view those MIP maps if you manually create a DDS file in Photoshop. On the Nvidia website you can get the Nvidia Tools. It's a free plugin for Photoshop which will get you the non-map filter, but it also gets you the ability to save as a DDS file. When you save as a DDS file, you will get this save dialog window, and here you have a section called 2D preview. If you take that, you can see the MIP maps it generates. So Photoshop also generates the MIP maps, it says very clearly here as well, when it saves DDS files in the same way that Unreal does when it imports and converts the texture. So when you do 2D preview, you will get to see this kind of window. And here you can see what it does internally. This is the original resolution, the original image. Then it made the second version, half the size, or 1/4 of the size rather. And it saved that in the same file, so this is a separate image. It made a second separate image, third, fourth. So these are different MIP steps. And if you move further away from a model, as said, it automatically switches to this texture instead. And then this one, and then this one, this one, this one, steps down. So technically, I could now make this guy pink, and then the moment you step away from the character, he would suddenly turn pink. This is a completely separate texture, not related to this one, once it's generated. The sharpen settings in Unreal will automatically make these sub-images sharpened as it steps down. This has a particular impact on things like a fence as well. I made a fence here. There, this is an ordinary rusty fence. Well, if I put that in a material, I can also show you what happens then, and this also ties into lot bias again. I'm going to multiply the texture with a bright color, I'll just increase the brightness so it's more easy to see in a video. And it has alpha, so I'll connect alpha to opacity mask. And set the thing to masked. Right, so then you have this. It's a basic rusty fence. Here's a problem for one. This happens very frequently with fences. If you look at a fence from a distance, it's gonna appear like this. At some point, you will probably recognize this. At some point, if you look at the fence from a distance, it looks more like dots than an actual fence. Well, that's because the MIP map is also stepping down. So you can see I now have lot bias on 5. This is a very particular case where I tend to offset the lot bias, trying to fit this on the window here, where I actually tend to type -1 in the beginning, so that when you move further away, you're less likely to see this, because you've offsetted the lot bias. So in this case, you might even do lot bias 3, for example. Now, if Unreal were to allow me to manually edit the MIP maps, which it doesn't, then what I could have done is I could have brought this texture into Photoshop, and then I could have manually made the MIP maps in Photoshop. I could have manually made a very low res image that would look better than this generated one. And that's kind of the weakness in this system here. But again, here's a very particular case why you sometimes want to use a negative lot bias in order to restore problems like those. Because you can see very clear here as well, if you move away, it begins to turn into dots. And especially if you play a game on a big screen, full screen, you can still see this. A texture like this might even do as well with no MIP maps at all, in fact. It probably looks better if you do that. Although you can see it gets a bit more pixelated and noisy, and now you get this, so it's not really ideal either. One setting that's not immediately useful for the character, although it is actually used, is the clamping. And the clamping setting is particularly useful for smoke textures and things. For example, I can in fact actually just get a smoke texture, so you can see what happens exactly. We are going to be using this feature on the gradient. There's actually a gradient applied to the whole character that controls the burning from his feet up to his head, and that's clamped. But a smoke texture will more easily explain what's going on. So I found a random smoke texture somewhere in one of the packages. And let's connect that to the fuse for a moment. And now let's say, so it's pretty much on a box now, let's say we want to rotate the cloud. What happens is that on the edges, you can see the next cloud because the cloud tiles, right? Every texture tiles. So this cloud is rendered here, but if you were to just continue it, it would tile and again and again and again. In fact, if I add a texture coordinate, you can see a tile. Because every texture does that, it tiles. So if you do that with a cloud and you rotate a cloud and you put it on a plane, you can see on the edges the next one moves in. That's really ugly. So the solution to that is by turning off the tiling of a texture and have it only render once. If you double click a texture, you get access to all the properties, and this is where we're going to be working in a lot in the first part of the video. At the top, it says address X and Y. It's wrap, meaning it's tiling. If I set that to clamping on both, and you don't have to save or re-import to do anything. Well, you have to save the package obviously, but you don't have to re-import. Any of these properties, the moment you change them, it changed, and it changed directly on the package. It doesn't require a re-import. But now you can see, you can't see it appear on the site anymore. And the reason why it happened is again because the tiling got turned off. So if I try to tile it, everything surrounding the first instance of the texture is black. What clamping basically does is it takes the last pixel found at every edge, so the last row of pixels over here and the last row over there, and it just stretches them out infinitively. So the texture never tiles anymore. This is something I can show you later on when we set up the whole material as to why this is important.